tan alpha equal to x sin beta by 1 minus x cos beta, and tan beta equal to y sin alpha by 1 minus y cos alpha. We have to show that sin alpha by sin beta equal to x by y. Now for this, since we have to get in terms of sine, so we'll split up this one in terms of sine and cos. So what we get? Sin alpha by cos alpha equal to x sin beta by 1 minus x cos beta. Now cross multiply. Sin alpha minus x cos beta sin alpha equal to x cos alpha sin beta. So sin alpha equal to x common cos alpha sin beta plus sin alpha cos beta. This gives us x sin alpha plus beta, and that is the value of sin alpha. We mark here by equation 1 and leave. Now we take this expression tan beta, so that we have tan beta equal to y sin alpha by 1 minus y cos alpha. So this gives us sin beta by cos beta equal to y sin alpha by 1 minus y cos alpha. Now if we cross multiply sin beta minus y cos alpha sin beta equal to y cos beta sin alpha. Now we take this part on the right hand side. So if you take on the right hand side, what you get? Sin beta equal to y. What we had? Sin alpha cos beta plus cos alpha sin beta. Sin alpha cos beta plus cos alpha sin beta. This gives us y sin alpha plus beta. And sin beta we are getting y plus sin alpha plus beta. This is equation. On dividing equation 1 by 2, we get sin alpha by sin beta equal to x by 1. And that is what we need to do. It is given tan theta plus tan phi equal to x. Cot theta plus cot phi equal to y. And we have to prove that cot theta plus phi equal to 1 by x minus 1 by y. So this is what we need to prove. Now, here, what we'd like to bring, we'd like to bring in terms of tan first. Yeah, tan theta, the first one we can mark this as equation 1, this one we mark as equation 2. Now from 2, what we say? Cot theta plus cot phi equal to y. Now from this 1 by tan theta plus 1 by tan phi equal to 1. Now from this tan theta plus tan phi divided by tan theta tan phi equal to 1. Now tan theta plus tan phi is given as x from equation 1. We can use that value. So x by tan theta tan phi equal to x by y. Tan theta tan phi equal to x by y. Now we have got tan theta plus tan phi. We have got tan theta minus tan phi. Now using both of these, if we mark this as equation 3, we can easily find tan of theta plus phi. What is the value of tan of theta plus phi? I'm going to by formula tan theta plus tan phi by 1 minus tan theta tan phi. Now tan theta plus tan phi is what? X by 1 minus x by y. Now this gives us what? Xy by y minus x. Now since we have to find cot, we can just take the reciprocal. So cot theta plus phi equal to y minus x by xy. Now if we take y by this minus x by this, we get 1 by x minus 1 by. Very simple. Here what we have done, tan theta plus tan phi is x, cot theta plus cot phi is y. Now cot theta plus cot phi is y. Now cot theta what we can write? We can write as 1 by tan theta. Cot phi is 1 by tan phi equal to 1. If we take the LCM, tan theta plus tan phi by tan theta plus tan phi. This is x by tan theta tan phi. So tan theta tan phi is x by 1. We are using here tan theta plus phi formula. So tan theta plus tan phi by 1 minus tan theta tan phi. Here we replace the value of tan theta plus tan phi from here. 1 minus tan theta tan phi, that is 1 minus x by 1. We have simplified, but to get the cot, just we pick the reciprocal and we are done. It is tan theta equal to 2x minus k by k root 3 and tan phi is given x root 3 by 2k minus x. And we have to find the value of tan phi minus theta mod obviously. That means you have to find the acute angle or that value for which is positive. Now how to find that? What we need to find here, you see, there is a modulus of phi minus theta. You have to show equal to 30 degrees. This is what we need to show. Okay, this is what we need to show. Now how can we start? First of all, we can directly find tan phi minus theta. What is our intention? To find phi minus theta. So if we want to find phi minus theta, what we can do? We can start it in this way that we have tan phi minus theta. So that will be what? Tan phi minus tan theta by 1 plus tan phi tan theta. So children, tan phi minus tan theta. So you have the value x root 3 by 2k minus 6 minus tan theta value 2x minus k by k root 3 whole divided by 1 plus tan phi, that is x root 3 by 2k minus 6 into 2x minus k by k root. Now here, this simulation will be easier comparatively because you can see root 3 getting cancelled out. That's the formula you have to put, nothing else. Now after that, we can simplify this. So if we simplify, if you take the LCM, it is 2k minus x into k root 3. So this will be what? Kx into 3 minus 2k into 2kx, that will be here minus 4kx. Now 2k into minus plus, so that will be 2k square plus 2k square. Okay, next minus into this one, so plus 2x square. Next, because this is minus 2 is minus 2. Now minus into minus plus into minus minus, so minus x minus k. Now the denominator, if we don't cancel it out, that will be better because you can cancel out the denominators very easily. So don't cancel it out. You keep it as 2k minus x into k root. No need of cancellation, so that we can cancel out this two denominator easily. Now after that, what we write? This whole thing into 1. So what we get? We get here 2k square root 3 minus kx root 3. Now after that, multiply 2x into this one, 2x square root 3, that is, you can say plus 2 root 3 into x square minus kx root 3. Now, why I have kept this part same, so that you can cancel out very easily. Now after this, you have to just simplify. So if you have to simplify, what you get? Here you see minus kx. Here we have 3k, so it is 2k square plus 2x square. This one at first you write 2x square plus 2k square. Rest part you have to simplify. Now here in the denominator, rest part will do, definitely will do. Now, here you have 2 root 3 x square, here you have 2 root 3 kx square. Now this part is there. Now at first you concentrate over this kx. How you have got kx from the beginning, you see. This was k root 3, this is x into root 3, so that was 3kx. Now how you have got this kx? This is minus 2k. So 2 into 4k into x. Next, minus x minus into minus into minus plus k minus kx. And here what you have got? Plus 3. So definitely what we get throughout, minus 5 plus 3 minus 2kx. So here you get minus 2kx. Now in the denominator, what you have? It is 2 root 3k square. You can see root 3 throughout. So you can take a root 3 common first. Now you calculate the rest part. This 2kx square plus 2x square. That you can write 2k square plus 2x square. Next part. Minus kx minus 2kx. And you see this and this cancel out. So this is what? 1 by root 3. Now tan of theta minus phi is 1 by root 3. So in this case, we can say mod of phi minus theta equal to that. It is given cos theta minus alpha equal to p and sine theta plus beta equal to q. And what you need to find out here, we have to prove that this is equal to this whole is true, p square plus q square minus 2pq sine alpha plus beta equal to cos square alpha plus beta. So this is what we need to show or prove. Cos theta minus alpha is p given, Sine theta plus beta equal to q given. And we have to prove this one. Now, there are many ways we can proceed. If we proceed this way, suppose here we need to have sine theta plus alpha. So you can start with that one. Sine alpha plus beta equal to sine theta plus beta minus of theta minus alpha. Now here it is sine of alpha plus beta, that is sine of theta plus beta minus theta minus alpha. Theta theta cancel out, alpha plus beta. Now this is sine C minus D or sine A minus B. Here this is what form? Sine A minus B form. Sine A minus B means what? Sine A cos B minus cos A sine B. So you can write out this one as sine theta plus beta cos theta minus alpha minus sine theta minus alpha cos theta plus beta. Sine A minus B formula, sine A cos B minus cos A sine minus cos A sine. Now we substitute the values. What is sine theta plus beta? Given Q. Into cos theta minus alpha, that is given P, minus sine theta minus alpha, that is root over of 1 minus cos square theta minus alpha. So that we can write root over of 1 minus P square into root over of 1 minus Q square. Now, as we know always that we take all the rational on one side and all the irrational on the other side. So PQ minus sine of alpha plus beta equal to under root of 1 minus P square into root over of 1 minus Q square. Now squaring both sides. Squaring both sides. Because in the proof part, we don't have any irrational part, so it's square. Now from squaring what we get? It is P square Q square plus sine square alpha plus beta minus 2PQ sine alpha plus beta equal to 1 minus P square minus P square plus P square Q square. Now you can see that P square Q square and here P square Q square is same. So that will get cancelled out. So we write here P square plus Q square minus 2PQ sine alpha plus beta equal to 1 minus sine square alpha plus beta. That gives us cos square alpha plus beta. Sine theta plus sine phi equal to A. Cos theta plus cos phi equal to B. And theta minus phi equal to A. Now how to find this? We have to get theta minus phi, but here we have sine theta plus phi and cos theta plus cos phi. So what we'll do, children, write down. Mark this as equation 1 and this as equation 2. Now let's squaring and adding. Why you're doing squaring and adding? Because when you're doing the squaring of the first expression, children, you will understand that you get sine theta sine phi. Here you get cos theta cos phi. So if I add them up, then you'll be getting what? Cos A cos B plus sine A sine B, that will be cos A minus B. Now this is sine square theta plus sine square phi plus 2 sine theta sine phi plus cos square theta, second equation. From second equation, we write this part cos square phi plus 2 cos theta cos phi. Now this is equal to what? A square plus B square. Now this gives us 1. This will give us 1. This will give us 1. Plus 1 plus 2. Cos theta cos phi plus sin theta sin phi equal to a square plus b square. And now from this one, what we get? 2 plus 2 cos theta minus phi equal to a square plus b square. Now from this we get cos theta minus phi equal to a square plus b square minus 2 pi. And now this value is given here in the question a, that is it should be alpha not a. So this is ultimately cos alpha equal to a square plus b square minus 2 pi. Very simple, just you have squared and added. When you are squaring and adding, this will be what? Cos theta cos phi plus and then sin phi. And then it will be what? Cos of theta minus. It is given tan theta plus tan phi equal to x. Cot theta plus cot phi equal to y. We have to eliminate here theta and phi. It is given theta plus phi equal to alpha. And we have to eliminate theta and phi. Now for that, what we do? We start with this x and y only because that is a given part. So we can write this one as 1 by x minus 1 by y equal to 1 by tan theta plus tan phi minus 1 by cot theta plus cot phi. Now we can simplify this. 1 by tan theta plus tan phi minus 1 by tan theta plus 1 by tan phi. This gives us 1 by just tan theta plus tan phi minus tan theta tan phi tan theta plus tan phi. Now if we simplify this, in the denominator we have the same part 1 plus that is tan theta plus tan phi here also, here also. So the numerator we can write 1 plus tan theta tan phi by tan theta plus tan phi. That gives us 1 by tan theta plus phi. That gives us cot theta plus phi. And theta plus phi is given as alpha, so it's cot alpha. Hence, theta and phi both removed. Or a. Now, first point is how to understand that here we have to take this one. 1 by x minus 1 by y. Children, if we do in any other thing x and y, then we will have tan theta tan phi in the denominator. So that will be difficult for us. But in that respect, if we take 1 by x, 1 by y, it is quite easy comparatively. Why? Because we will have tan theta plus tan phi in the denominator. And then we can simplify.